So for this particular question, we need to find the derivative, and we need to state in each case what u and v are, and then we need to find the values of x that make the derivative equal to 0. So we'll start by looking at the question. Should I expand this one? No, because it's a power 5. That would be more complicated than if I just used the product rule. So I'm going to start by writing the derivative, which is the first term times the derivative of the second, plus the second term times the derivative of the first. And then we need to do some tidying up. I can see that I've got a common factor of x plus 5, and in fact if I've got 4 of them here and 5 here, I can take 4 out in total. It means I've used up all of those and all but one of those. And what I'm left with is 5x plus one lot of the x plus 5. X plus 5 to the 4th times 6x plus 5. That's my derivative. I need to find where this is equal to 0, so the process there is to set the derivative equal to 0 and then solve. If this equals 0, then either the first term equals 0 or the second term equals 0. So I have x plus 5 equals 0 or 6x plus 5 equals 0. And then I just solve each of those to find where the gradient is 0. Similarly for this next question, I look at it first, make sure it's not going to be easy if I expand it. In this case it's not, because I've got a cubed and a power 4. So I go straight into finding the derivative. The first term times the derivative of the second, plus the second term times the derivative of the first. Again, we'll look for some common factors. I've got some number of x's I can take out. There's 3 in this term and 2 in this one. So I'm going to take out an x squared, which would use up all of those and all but one of those. I'm also going to look at the x plus 1's. I've got 4 of them in this term and 3 of them here, so I'm going to take out 3. Uses all but one of those. What that leaves me with is a 4x from the first term and one lot of x plus 1 in the second, which is still times by 3. Just neaten all this up a little bit. 4x plus 3x is 7x, and we've got a plus 3. We want to find where this equals 0, so we set the derivative equal to 0 and then we solve. In that case I've got 0 equals to my derivative, 3 things being multiplied together that equals 0, so either the first one is 0, the second one, or the third one. So in this case, there are our 3 responses for where the derivative could equal 0.